fair. At least it's a fairly normal name. All right. So on this screen, there's a whole lot of going on here. What this is really boiling down to is that your polynomial is going to have n roots if your degree is n. This sentence kind of sums up the whole page. No. Okay, great. I put them up because they will come back. You will see this again in calculus, and you'll see this again in higher level classes. I have literally written this theorem down in every single math class I've taken, including the one I'm currently in. So the fundamental theorem of algebra is one of those things that comes up, and all it is if it has coefficients that are made of numbers, it's gonna have at least one root. Whether it's real or imaginary doesn't really matter, but it's gonna have a root. That's what the first one says. It has a solution. We'll be able to solve it. And then the second one says whatever your degree is, it's gonna have at most that many roots. So it's not gonna have more roots than your degree. So it's things we know and that we've worked with. It's just putting it in our mathy language. Okay. So we're going to be working with zeros and roots and that kind of stuff. But again, that last sentence is the kind of big sum up of the whole page. This sentence at the top, you kind of want to have. This is called multiplicity, and this is really what we're talking about today, is multiplicity, which sounds like a movie title. I believe it may have been a movie in the 90s. But multiplicity in terms of math stuff, it's how many times a factor occurs, like a double root or a triple root. So we've worked with multiplicity before. We've just never given it a name. So most roots have a multiplicity of 1, meaning it's a single root. It's our x-intercept. A multiplicity of 2 means it's a double root, so our factor will be squared. A multiplicity of 3 would mean that factor is cubed. That's all the multiplicity means. So what we're going to do on these 3 examples here is we are going to write in factored form an equation that has these pieces. So we're going to write an equation for a polynomial that has zeros at 2, 4, and -1. It's going to be a degree 3. Because there are 3 zeros. Which means if we were to multiply it out, we'd wind up with an x cubed. So how do I write a factor that's going to give me a 0 of 2? X minus 2. How do I write a factor that's going to give me a 0 of 4? X minus 4. Okay. And a factor, all right, what is a factor for a root of -1? X plus 1. Do we know what our leading coefficient is? No. So we are going to put A. We do not know what it is. So this would be any polynomial that has zeros of 2, 4, and -1. And this one has a degree of 3. We don't have to do anything extra with a degree. It's kind of going to be our double checker. be sad that I'm out of coffee. So then we're going to look at part B, and part B is talking about the multiplicity in here. The default state, if we don't tell you what the multiplicity is, it has a multiplicity of 1. All that means is it's got the invisible exponent that we never write on stuff of 1. Sorry, usually have that locked out. So when we're writing our factors, if we have a multiplicity, we're going to put that as our exponent. So how do I write a factor that has a 0 of 3? X minus 3. And if it has a multiplicity of 1, it doesn't need an exponent. How do I write a factor that has a 0 of 1? X minus 1. It has a multiplicity of 1, so it doesn't need an exponent. How do I write a factor that has a root of 0? X. You can write it as x minus 0. I genuinely don't care. But it's easier to just write x. But this one has a multiplicity of 2. X squared. Does this now have a degree of 4? Yes. Do we know our leading coefficient? No. So I'm going to put an A. And that's our function rule. Okay? So then we have C. We've got a 0 of 2 with a multiplicity of 1, a 0 of 1 with a multiplicity of 2, and then 3i. I am not going to have enough space for this one. There we go. We're going to need a little more space. And there's a couple of weird things with the 3i. But we'll do the first two first, and then we'll get over to 3i and deal with it. So how do we do our factor that has a root of 2? X minus 2. Easy peasy. How do I do a factor with a root of 1? X minus 1. And it has a multiplicity of 2. So the factor is squared. Whenever we have imaginary roots, it gets a little weird. Because what an imaginary root is like a non-intercept, right? So there's never just one. It's always plus or minus, right? So we have plus or minus 3i. Whenever we have an imaginary root, it's always a double root. Always has a multiplicity like that. But also, like, when we write this as a factor, have you ever seen an I in a polynomial equation? No. So we are not going to have any i's in our equation. We're going to have to multiply some things together because we're not going to have i's in a polynomial. So we're going to write our factors here just like we did with the others. X plus 3i and x minus 3i. We have a plus or minus. Like I said, we don't want to have i's in a polynomial. That's not good. So let's multiply it out. We're going to have x squared. What?
X squared. Oh, plus 3i minus 3i, so it just cancels.
Yep.
9i squared, which I squared is -1. So
Yeah. So this factor is going to be x squared plus 9. Because that's a difference of squares, so the middle terms cancel out. I squared is -1. So our factor that goes in our polynomial is x squared plus 9. We're not going to have polynomial equations with an I in them. I'm just doing that barrier so we don't think it blends with the other blue words there. So imaginary roots always have a plus or minus, and we have to multiply them out. Yes, dear.
We also have the A.
Yep. Yeah, I just haven't finished my equation yet. Right now it's just an expression still. So to get this as an equation, our function rule, we don't know our leading coefficient, so we're going to put an A. Guess what we're going to find on the next page? We're going to figure out our leading coefficients. Here, Joanna, let me zoom it out so you can see the whole thing. I got you. Okay, so they're a little weird, and the wordings are weird. But once we get the hang of it, it's not too bad. Okay. So we are going to be writing a polynomial in standard form for this one. And that means I am actually going to do a thing. Okay. I'm actually going to cover up the bottom one just so that we can use all that space. And we'll do that one on the next page. Just because I'd like us to have plenty of space for this. Okay. So we're going to be writing an equation in standard form. Standard form means we're going to have no parentheses at the end. So we're going to multiply the whole thing out. So we're going to start with getting our factors. So we're going to have a factor that gives us a 0 of 4, x minus 4. We're going to have a factor that gives us a 0 of 1, which is x minus 1. And a factor that gives us a 0 of -3, x plus 3. This is our function rule where we don't know A. Making that A look like an A, not a 9. Okay, so it's just like we did yesterday, or not yesterday, on the last slide. I'm good with nouns. And we are told that f of 6 is 180. So that means to me that when x is 6, f of x equals 180. So we're going to substitute those two values in. That's going to leave us with just A left over. So substituting that in, we're going to have 180 equals A times. Are you asking me what I'm talking about, or are you talking something else? Are you asking what I'm talking about, or are you talking about something else? Because I know you guys tend to have like 3 other conversations happening at the same time. Okay. Did you figure it out?
Yeah.
Okay. Just checking. Saying it's really hard for me to tell if you're asking me a question or if you're asking him a question. That's not relevant. So I'm going to substitute that 6 in for x every place I see an x. So we're going to solve this. 180 equals a times 6 minus 4 is 2. 6 minus 1 is 5. And 6 plus 3 is 9. What is 2 times 5 times 9? 90. So 180 equals 90a. So what's a? 2. So now I have an a value of 2. So I can go back to my equation and fill that in. I'm going to bring this over here. So my f of x equals 2 times x minus 4, x minus 1, x plus 3. And oh, that looks weird. That looks like a B. Fix that. Better. Tiny, but better. And if they just asked us to write a polynomial, we'd be done. But they didn't. They asked us to write a polynomial in standard form. We got way too many parentheses here. So we multiplied out. Okay? So I tend to multiply in pairs because it's way easier. So I'm going to multiply these two pieces, and I'm going to multiply these two pieces for my first set. So I'm going to have that my f of x equals 2x minus 8 and x squared minus 1x plus 3x gives me plus 2x minus 3. If you need to draw your box, draw your box. If you want to write it out and distribute it and then combine like terms, totally fine. If you can do it in your head, excellent. Whoa. There we go. It's still there. Then we're going to multiply again, but this time I have a binomial trinomial. So we're going to have a whole lot of terms. So I'm going to scooch over a little bit. F of x, and I'm going to do this with distribution. We're going to have 2x cubed plus 4x squared minus 6x. That's distributing out my 2x. Distributing the minus 8, we have minus 8x squared minus 16x plus 24. And we're going to combine our like terms to get our polynomial function rule. F of x is what? What do we get? 2x cubed minus 4x squared minus 22x plus 24. Just giving us a little barrier there so it's easier to see where things switch. So there's a lot of stuff on the screen here. That's why I made it so that we had more space. Questions on this one, because this goes through a whole lot of things.
This whole kind of testing. In the quiz.
This will not be on the quiz tomorrow. This is section 4.3. We should never have the notes from the day before on the quiz. There should always be a day break in between.
That's nice.
Because that's just like
I
not
feel
fair.
all teachers do that. I wish.
True. True.
Did you smile in your driver's license picture?
I mean, her.
Yeah. I don't think you can't like cheese it,
Not with
but
the teeth.
yeah.
Yeah, no teeth, I think.
Yeah.
My dad looks constipated. He looks like it's a mugshot. That was.
Sometimes the person is very picky, especially if it's the if you use the same photo for passports. Because passports you can't smile even. Like you have to be like
Well, I smile.
super
At
serious.
the airport, I look fit.
You have to be super serious in your passport photo. So
I smile for my passport.
He's better than you.
They let me. Maybe you just went to a nicer.
you went to a nice person because they're like the passport people might not accept that picture.
I mean, you have to be able to see your eyes, but they let me do like a little like. Yeah. You just can't smile with your eyes. You have to look dead inside your eyes.
A little bit. Okay. Let's do another one like this. Yes. All right. Let's see if I can fix it. Because it's the bottom one on here, because we just did the top one. You okay? No, that is not what I meant. Okay. So we'll just write our equation and then I'll erase the bottom thing so that we have that space. So let's write our polynomial first, our f of x, for when we don't know our a value. What are my roots going to be, or my factors going to be? X plus 1, x, x minus 2, and x minus 4. So we're given the zeros, and we just got to plug it in. Then we need to solve for our a value. Slay. This is my x. And this is my y. Or my f of x. So we're going to substitute those in so that we can solve for a. So we're going to have our 63 equals a. And we're having our 1/2 as our x. 1/2 plus 1. 1/2. 1/2 minus 2. And 1/2 minus 4. What is 1/2 plus 1? 3/2. 1/2 is still 1/2. 1/2 minus 2? Negative 3/2. And 1/2 minus 4? 7 halves. Because 4, you could write it as 8 halves. 1 minus 8. Okay. So they love to throw fractions at us because it makes things gross. Ooh, I really changed in size as I went from left to right there. That's okay. That's what happens when you don't have line paper. And I have it zoomed in so far. All right. So we have 63 equals A times what? So remember when we're multiplying fractions, multiply across the top. So 3 times 1 times negative 3 times negative 7. 63 over 2 times 2 times 2 times 2. How do I figure out what A is? Multiply both sides by 16. And divide by 63, right? So 16 is the A, positive 16. So again, now I have my A value. And if they ask me just for an equation, we'd be good, but they want a standard form equation, so we're going to go back up to the top, multiply the whole thing out, because they like to be extra. Shock. So I'm going to start by putting that A value in. We're going to have our f of x equals 16 x plus 1 times x times x minus 2 times x minus 4. And I am incapable of keeping a scale the same. Or writing in a straight line. Either way, doesn't matter. Because I have a plain white screen. I don't have any lines to give me hope.
There should be a setting that you can turn on those lines.
But then it would have to be over the whole screen and y'all would see it, and I like the plain white better. It's prettier. And so we're going to multiply this out. And I'm going to take all of these pieces it wants to multiply out, and I'm going to do these 2 pieces it wants to multiply out. So my function rule in this kind of in-between stage is going to be 16x squared plus 16x for the purple piece. And then for my right-hand piece, we have x squared minus 2x minus 4x gives us minus 6x plus 8. And again, we have a binomial trinomial multiplication here. So we're going to distribute the heck out of this. F of x is 16x to the 4th. And we are going to have some really big numbers. 16x squared times negative 6x. 96x cubed. 16x squared times 8. 128x squared. Luckily, our coefficients between both of our left terms are the same, so we don't have to remath it. We love that. It's just different variables. So then we're going to take our 16x, and we're going to distribute this guy. 16x cubed. I'm going to go down onto the next line just because I'm out of space. 16x times negative 6x gives us negative 96x squared. And 16x times positive 8 gives us 128x. And we're almost done with this one, which we'll do as our last one. This will be our last one today. We did a few at the beginning, yeah. So we're going to have f of x is 16x to the fourth. What is our coefficient for the x cubes? 80. X cubed. How about for our x squareds?
90.
Yeah, 32x squared. How about for our x's? 128. There's only the one term. And do we have a constant? Nope. We don't have a constant. The y-intercept is at 0, 0. You got it. You got it. We can also kind of tell that because it has a 0 at 0. So, but that's okay. All right. So, we'll do some like this tomorrow where we're going to take pictures and write equations, but we'll do that tomorrow. Okay, so that is 4-3. There's the homework questions for 4-3. We're going to have 4 minutes where you guys can ask questions if you have them, or you can just chill, whatever we need to do. But that's going to be the end for today.